Hello, everyone. I'm Lawrence. I'm going to be one of your co-leads for this workshop today, and I'm joined by Jonah.
Hello.
So today we're going to be going over Unity and GitHub. Actually, more so, this workshop will just be focused on Unity, but the GitHub portion will be a video that we'll be sending out later today. So first of all, we want to go into what exactly is a game engine. And a game engine is essentially just software that helps developers in the creation of video games. Took that right from Wikipedia. Um, so there's plenty of benefits to using to using a game engine. It's a lot of times you want to use a pre-made game engine because it's first of all it's cost effective. Lots of companies, like whenever they try to make their own game engine, it costs them like hundreds of millions of dollars just to like create an engine that works for them. And I guess the pros to having your own custom engine is that you could do specifically what you want with it, but like the amount of time and resources you spend on it, it's cost a lot, so you have to make a lot of use out of that. I know EA uses their like Frostbite engine for a lot of their games, but then recently they switched over to like a new or to an existing game engine because it's just like it was just too much money to maintenance, and it was just easier to license to a different game engine. And second, most game engines already offer like systems that the programmers don't have to develop for themselves. Like a lot of times you think about like the physics of a game or even like something as simple as the sound. Uh, Game engines already have those systems built in, so developers don't have to program everything themselves. Like they can still program it to edit it how they want it to be, but it's still a lot easier than creating it straight from scratch. Here we have some examples of like very simple game engines. Game engines don't exactly have to be coding. Like an example would be Super Mario Maker, or Super Mario Maker is probably like the best example I could think of like a very simple game engine where you don't have to program anything. Scratch and Dreams, there's like a bit more complexity to it. Like you have more control, and like basically the more complex your game engine gets, the more control you have over it. Uh, like with Scratch, if you guys have done like an hour of code in your school, I know I have. You can make like a simple like Flappy Bird mini game or something. Dreams is a PS4 game where you can just like create models, and you could like put like a bunch of like branches of like telling the game like how you want it to run, but it's not. So those are just like two like simpler game engines. An example of like an actual like industry game engine would be something like Game Maker Studio. This is something that you see typically in more 2D related games, something like Undertale or Rivals of Aether. They tend to focus more for Game Maker Studio tends to focus more on 2D pixel art, and then but this game engine does cost some money. I believe it's like a flat fee for you to use it. One of the more popular ones that tends to be used by a bunch of larger scale gaming companies is the Unreal Engine. The Unreal Engine has created games like Fortnite, Mortal Kombat, Final Fantasy VII, and Guilty Gear, which kind of just like shows you like how like customizable a game engine can be. Like it can create all these different types of games and all like different styles depending on how the user wants it to be. And they've even broken into the movie business with the Mandalorian. I know like Disney used that for their show. And then last but not least, we have Unity. Unity is something that a lot of indie devs tend to go to. You see uh, people like Team Cherry. They created Hollow Knight, and then some other developers like the team. I think
Video
Moonlight.
MDHR with Cuphead.
Yeah,
And
yeah,
even Blizzard made Hearthstone.
yeah, yeah. So now we're going to be. So I guess some of you might be asking, like, why are we using Unity specifically? First of all, it's one of the most popular game engines out there, and because of that, there's a lot of tutorials available. So if you don't know something, chances are it's probably somewhere online. Like it's very easy to find ways or tutorials online to help you create something in Unity, and like you could just like do a quick Google search, and it's probably within like the top 5 results. Uh, a lot of, and also it's pretty good for beginners and like new programmers, because a lot of times schools have their programs run where Java is like the first language you learn, and we're using C sharp, which is essentially just Java. It's like the same syntax. There's like, I think there's like a few differences, but like I haven't really noticed much of those differences here or there. And the advantages of Unity, it's free at no if you're just using it for personal use, or like even like if you upload the game, if it doesn't make like a certain amount of money, you could use the engine for free. It's also really good for beginners and very popular with indie teams, as I mentioned earlier. There's also a really well-crafted asset store. Like if you're not really strong in 3D modeling or 2D design or even sound, you could go to the asset store, and then they have lots of options for you there. So and a lot of it's free too. Like you could just like go and just join some free assets, and then it's pretty easy to create your own tools, and it's also the engine used for Among Us. Some disadvantages with it. It's not really meant for AAA games, and that's why a lot of indie devs tend to flock to it. But like, you don't see much AAA studios going for it. As the slide mentions, it's originally created for web development and JavaScript, and there's not a lot of like art support for it. Like you can't like model your own thing, or you can, but like there's some limitations to it. Unlike something like Unreal or other things. So, are there any questions in regards to that? Now we're going to be going into the actual tutorial portion of this. So open up Unity Hub, and you should see this page right here. And then when you click New, you're gonna see a lot of options right here. Right now, we just want to do a 3D. We just want to test out with a 3D project, and you just type something like workshop 1 test or something like that, and then you just hit create.
It's also important to have your own folder for these games so they don't get mixed up with other like folders.
Yeah, that's a very good point. Later on, when we switch over to Jonah's stream, we're going to be seeing like an example that he made for the workshop specifically. But right now, it's just empty. So here we have your scene. If you hold the middle mouse button, you could scroll around in it, and then you could also zoom in. You could zoom in, zoom out, and then scroll to move. And then if you hold shift, and then the middle mouse button, you move a lot faster. Then if you try holding down the right mouse button, you could change the angle, change the rotation of your camera, of what you can see. So this is considered the scene window, as you can see right here on the top of the tab. Now, if you click on the game window, you're going to see something different. Here, you don't really have any control over anything. Like you can't touch anything. Everything here is just like, you can't move anything at all. This is because when you go back to scene, it's all from the perspective of this camera. This is if you guys have used something like Blender before, which I'm not sure if some of you have, you're usually used to seeing like an actual like camera shape on there. But for now, the camera is just represented by this image, and you can see on the bottom right hand corner that it will show you exactly what's in the scene. And then something that I find useful, especially later on when you're bug testing the game, you can move the windows up here like tabs. So you just move the tab over here and create a new window. That way you could have both your scene in play and your game as you're testing the thing. And then you could just move it back when needed. We're going to be going on the left-hand side of the screen where it says the hierarchy. And here you can see where all of your objects in the scene are. So here you could see stuff like your camera or your directional light. If you click on the directional light, you'll see like what direction it's pointing in, of course. And then here you could hit right click and then 3D object, and we want to add a cube. So as you can see on the right hand side of the hierarchy, you can see that that the cube that we added is there. Uh, for sometimes when you add in an object, it won't go straight to 0, 0, and it will be like a bit off center. Like here, it should have spawned like where my mouse is right now, but it spawned somewhere else. So you always want to check that, especially when you're adding in a bunch of assets at once, because sometimes like if something's in the wrong position or where you don't think it is, then it could like screw up like your playtest. So here, when you look on the right hand side, this is the inspector. This is where all of the information of the current object you have selected. For 3D objects, most of it will be about the same when you're first looking at it. But like something like the camera, you could change the background here or something, like change the window right here. But for the cube, since we're here, you can change its position to go back to 0, 0 or 0, 0, 0. And all you have to do is just go to position, type in 0, 0, and 0. So now it's perfectly centered. You could also change the rotation of it all in here, and then also change the scale. Now, you might be thinking doing it through here is a bit inconvenient, which is why we have shortcuts. One of the main when you first select on the object, the default shortcut should be on the move tool. So the move tool, if you're not on the move tool right now, you could press W, and then you'll be able to just like move it through the arrows right here. When moving an object, if you want to get it like really specific, you can click on the direction you want it in, and then hold Control, and then it will snap. It will basically like snap it by every 0.25 like units, and then you can snap it so it's a lot more precise that way. So as you can see here on the right hand side, the Z-axis is going a certain direction, or only by 0.5 intervals. And then for the next thing, you probably want to try and rotating an object. Rotating an object, you just press E, and then you can rotate it on its different axes like this. And then the white outline for the rotate is just like the rotate from your point of view in the scene. So yeah, something like this. If you want to rotate it like a specific way, but you don't want to use all three directions to like fine tune it, you can get like a large rotation right here. So I'm gonna reset the rotation back to 0. And then we have the scale. Scale is used to increase size. So you can increase size like by axis, or you could increase size of all three axes by clicking on the middle one and then moving the mouse. Are there any questions in regards to those?
Wait, how do you get out of the rotating?
So
mode?
To get out of the rotate, you could either click W or R. W will put you back into the move, and then R will put you into the scale.
Oh, okay. Thank you.
Yeah. And then there's another one that's like usually you use this more for UI or HUD design, like when you're creating for your game, is T. T is just like a rectangle tool that you mainly use on like 2D axis. I think you'll also be using this a lot more, especially if you're doing a 2D game. But it's just like a nice thing to keep in mind. All right. And if you want to leave any of these options, you could always click off from the screen, or click off from the object that you're on, or click onto another object. And then if you want to just reset it back to move, just always press W. Now we're going to go into the actual information on the inspector. The inspector is your window on the right-hand corner, or not the right-hand corner, but the right-hand side of your screen. Right here, we have the mesh filter. The mesh filter is something that, especially when you're doing 3D objects, when you're working in 3D, you'll be using this a lot. It's just like telling the computer or telling the game engine like what mesh you're using. Like a mesh is basically the form of the 3D model itself. So it's just telling the computer what 3D model you're using. The mesh renderer is telling the computer what it should see and how would light interact with it. So right here in under materials, you have the default material, which is what it comes with. With lighting, you could like make it turn off shadows if you don't want certain shadows. You could tell it how light reflects off it. So like if you want something like a mirror, you could do something like that. And then we also have down here the box collider. The box collider tells the game like how it would interact with other things. So let's see. If we add another cube, and you don't have to do this, I'm just doing it for an example. If we add another cube, and then let's say like we make it in the game, we say, oh, let's say this cube is a player. And if we want, let's say the player has to walk to this cube to switch to a new scene. When you're programming it, you'll say that when it collide, when the two objects touch, you'll switch to the next scene or to the next room or something like that. So I'm not going to program it right now, but like when you go and it touches the object, the box collider is what tells it, it's like, oh, it touched my boundaries. So now we move on to the next scene. So if you want to ever try renaming your object, you can always go to the top of the inspector where it says cube. You could rename it to whatever you want it to be. So like maybe you want it to be a banana. So you rename it to banana over here. If you're like really zoomed out and it's like a huge scene, let's say you're like in a city and you're like trying to model something for a battle royale and you need to find like a specific car, but you don't know like how to zoom into it. Instead of like clicking on the thing in the sample scene and then zooming in a lot of times, you could just press F and then it will focus in on that object right there.
You could also just double click the name of the object you want to do under your hierarchy.
A lot of things in Unity kind of have like a double, like there's multiple ways to accomplish it or to do what you want it to do. Like with moving position, you could just type specifically what you want, or you could move it via mouse. Now, if you want to try and duplicate the object that you already have, you can just simply do Control D, and that will create another one in the scene. If you duplicate like a specific object, it's going to remember everything that you placed on that previous object. So if you place any scripts or code, if you place a certain like color or material on it, it's going to remember all of that information, and it's going to duplicate it in the exact position, rotation, and scale that you have it right now. So usually you just want to move it out if you want to see both of them at once, like that. So now we have two bananas. And it's just going to label this new banana as banana 1 because it starts at 0. All right. So when you want to try and attach one object to another object, like let's say like you're a player, you have your player model, and then you want him to be holding a gun. Typically, how you want to pull that off is that when you have the second model, let's say let's actually increase the size so it makes more sense. Let's say this is the player, and then this is your gun right here. Like you're doing a shooter. This is how you do it. So you usually want to like match it up with where you think the gun will go and stay. And then you could drag on the left-hand side, you could drag. Okay, let's call this banana gun. You could drag the object that like the gun in this case, and then move it underneath, move it on top of where it says banana, which is like what the player would be. And then basically what this allows you to do is that if you click on banana and you move it, the gun will move along with it. And then usually you call the one that's on the top of the hierarchy the parent, and then you call anything that's underneath it the child. And then as Jonah mentioned earlier, prefabs are something that he'll go more in depth into it, but if you, let's say you have this character already and you made him in your scene with all of the code and the colors that you want. Now, you don't want to have to like redo that all the time. So, and instead of pressing Control D, and let's say you want to put him in like another room, instead of like creating him from scratch from another room or holding him in like a Control C and then trying to paste him into a different scene, you can drag the player down here to assets. And then what that'll do is create something called a prefab, as Jonah mentioned.
Mm-hmm.
And basically,
you won't have to worry about accidentally deleting your thing because prefabs will stay unless you delete it directly from your project tab.
Yeah. So let's say we want to have another banana person. We could just slap it in right there and it's all set up for you right there. And then if you want to try and edit a prefab in order to like, let's say I want the gun here to be like wider, but you don't want to, of course, we don't want to edit every gun in the scene. So if you just want to try editing one gun, you could go to prefab of the banana. And so there's a tiny arrow like right here on the right hand side of the name. And then you click on it. And then you go to banana gun. And then you just have to scale it as you want. So I want this like longer or something. Like you can increase the size there. And then when you go back, both the prefab and both prefabs are going to show up with a larger gun. All right, now we're going to be going into colliders. We already went over the box collider and what that example is. You could click here if you needed to like trigger something. You could click right here, and then you could also edit. Like, let's say your character has like a ghost hand or something, but you don't want the hand, like the ghost hand, to be like shootable or something like that. You can edit the collider right here and then change its size. Right here, you see like three like vector looking things, and then you could change its size. So then that would like lower or like reduce the size of the hand. When you change something here, it won't reflect on this prefab. Like this prefab, the collider information is still what it originally was. So what you want to do is if you want to apply it to here, you have to go to the one that you edited and then right click on it and then put modified component and then apply to prefab. But since we don't want to do that, we can just revert. So now we're going to try and give like our character like some color and like give it a bit of a material. So materials are essentially what you use to, as I said, give something like a color or a texture. Like a lot of like in the ground, like if you look on the ground in a game, you typically see like dirt, and that tends to be like a dirt material or dirt texture. So here we're gonna go to at the bottom of our where the assets are. We're going to hit right click, and then we're gonna go to create, and then we're gonna click material. It should be in the middle from the create. And then you could just name it whatever we want. Like here, we're just going to name it person. And here we have a bunch of different features for the material. The albedo is usually just like the color. So down here at the bottom, you can see like what type of color you're changing your thing to. So you see all of the changes and it reflects down there. Now, usually, so since we're going with something simple, you can just like change the color here. But in a lot of more complex games, like especially ones that where there's like more detailed characters, you usually have these things called maps. And like maps are used to add to the material. So they each map like contains different information. And have you guys ever made like a Minecraft skin and then like you download it and it turns into like basically they like flatten out the skin, like they unbox the character and then they just like place it there with, so basically you're just doing that. That's what maps contain. They contain all of like the color and information of like the thing that you like you're boxed up, And then when you apply it to your model, it will just like rewrap it over the model to make it actually fit. So here with metallic, it's just like a thing to make it like whether if you want it to look more metallic or not. Uh, and then here with smoothness, it kind of determines like the shine of it. Like how much light do you want to reflect off it, or like how shiny do you want it to look? So you could get some like cool like reflective effects using this one. The normal map and the height map are interesting because they're not we can't directly affect them from just Unity's basic settings because there's something that you do when you're 3D modeling or texturing something. So then with these two, you can they're usually like an image, same thing as the like the unwrapped thing, and then you'll just like throw it. You just place it on in like this little box right here, and then you'll be able to add in like a map, and it just adds the texture to it adds texture to your whatever you're doing. So like you if you want like a character like a monster, let's say, to have like rougher like scalier skin, you don't have to model every scale yourself. You can just get a text a normal map of the scales, and then you could apply it on there and it will show up, and then the scales will make it look like it's like 3D. And then with here we have emission. Emission is just like it's like the lightness of like the thing. So it could like if you want to make like your character glow or something, or like if you want to make a flashlight like have like a glow look to it, you just increase the emission, and then it will create a brightness. And if you make it like a different color than like the base thing, so let's say, so our thing is red right now, but let's say I want to make like a yellow emission. That depending on how bright you make it, that emission will overshadow like the color on whatever you do. And then you could just change it back to black when you're when if you don't want any emission, or you could just turn it off right there. All right. So um, now we're going to apply the material to our character. So let's click on banana, the first banana that we made, and then right here on mesh renderer, you can see where it says element 0 default material. So what you do is that you drag our material here and then you just throw it in there. And then there, it automatically applies, it wraps itself around the object. And here you have the red, like person. And then as you can see, it doesn't apply to this one. So if we want to make it apply to that person, you can right click on here and then put apply prefab to banana. So then that will make banana 1 also a person. So now I'm going to hand it over to Jonah, who will start streaming his screen, and then he'll be going over some other things like scripting and running the game.
So here's what my model is. I have 3 people: our enemy, ally, and the player. We're basically in an arena, which is also a prefab. And just right now, I copied and pasted my player movement script for one of my older projects. When you open the script, it should look like this. It's basically labeled your name of script.cs because it means C#. Your three default lines of your script is gonna say using system.collections, using system.collections.generic, and using Unity engine in upper camel case. And always your scripts come with 2 functions: void start, which is basically your starting conditions of your player, and void update, which is basically what happens to your character when he does his stuff. And basically, all this does is make him move. And then if you want to see the game run, you click this play button, and sorry, just checking my thing runs. you basically have the view of the game. My thing isn't working as of right now, but if I wanted to stop it and go back to working, we can click play. Now, another idea, if you're just playtesting it, is to split your scene camera with your game camera, so you can see your person move, and you can see when it works, and you can see your player what works in the game. And some parts of a script, they require different using statements. If you want to do Unity Engine and work on the UI, you have to type in Unity Engine .ui. If you want your game to transition through different scenes, which is like different parts of your project, you type Unity Engine .scene management. And if you want to do AI, that's Unity Engine .ai. So in some cases, you're probably going to get an error. So if we get a compiler error or something, an error related, our console is going to notice. Well, if there's an error, you check your console and it'll direct you. And if you click an error, which will be noted in red octagon with an exclamation point, it'll take you directly to the script that needs to be fixed. So if you see an error, don't worry about finding which script it is and having to click it. You just click it and your script opens. And you can even have multiple scripts from Unity open on the same page. So you won't have to have several windows. So I'd say there's some parts of a script that might require you to make changes on the Unity page and on the script page. But some of the data types you add on the script will be able to be added on Unity. These are my characters, and let me just. Some parts will be normal, like you can drag objects into tabs. Well, I've the ones that will make it work. And other times you might need to add like gravity check for some of these. It's basically your script is essentially giving you all the stuff you want to need, and your inspector is helping you adjust it without scrolling through hard, barely readable for some people programming languages.
It's essentially just writing like variables, and then the inspector allows you to just input those variables on the fly. That way you don't have to keep on going back into your code and then like trying to type it out within your code. You could just adjust it right there within Unity.
It's also probably going to be more readable for some people who aren't in CS majors or taking a course related to computer science.
When adding a script to your game, usually you want to hit right click and then create. Then you do a C# script right here. Remember, when you're writing a script, never add spaces to the name. Never add spaces to the name because it just like kind of complicates everything. If you're going to like do something where there's like a word, you just want to capitalize that new word. So let's say player controller. It's just going to be something like that. So yeah, was everyone able to create a script? When you open it, this is like kind of what you see. Like it's very similar to what Jonas was, but you don't like see all of the code that he already wrote on his. And how it works is that you have your class up here, and then here in void start, as the comment suggests, as the comment says, not suggest. This is like what happens like when you first start out your game. So stuff like here is where you want to set up your variables. So let's say we make something like game object player, and then game object player. Oh, I should probably make that public. Type in public game object player, and then here you want to set like public int damage. You can try and set the damage over here. It's equal to damage is equal to 5. So just like something like that. And then here is updates. So if you want to, this is called every frame. So you have to keep that in mind because sometimes if you don't keep that in mind, you might accidentally create something that will update every frame and eventually just like crash the game if you're not careful with it. So we're gonna do something simple for now. I see your question, like something like player movements. Next week we're gonna be going more into player movements, but for now we're gonna do something in the debug log. So if you go back to Unity over here, you can see somewhere here where it says the console. The console is where you'll do a lot of debugging, which is essentially like checking if like certain things are playing correctly. Like if you let's say like this player is shooting this guy right here, but like you think it takes 3 hits to kill him, but it for some reason it's not killing him. You could go to the debug log or the console and then program it so that it shows you the numbers here, like says how much health he has left. So let's try and do that. For here, it's updated every frame. So let's say when the damage goes to 0, or here, let's have the damage at 60 right now. And then let's say when the damage goes to 0, it's going to say display saying there's no more damage. So we could go damage and minus minus. So that's basically minus minus is just telling it that it's going to subtract 1 every time void update plays. And since void update is played at every frame, it's going to be every frame, it's going to be subtracting 1 from this variable damage. And then we want to try setting up an if statement. If damage is equal or less than or equal to 0, we want to debug log and then say, and then make sure put a parentheses and then put quotation marks and then say damage is equal to 0. So remember to always save your thing, because if you go into Unity, it won't update. So you have to, I usually just save by doing Control S, but you could also save by going to File and then Save right there. All right. So let's go back to Unity, and it's going to start reading the script again to see if everything is right. So here we're going to be adding our script to our player because it's not actually in the game itself. It's only here in like a folder. It's just, so it's not in the game. The computer isn't reading anything from it. So we add the script to here. We could just drag it in, or you could do add component and then just type in your script like player controller, and it's right there. So here we have the player controller script. We can add 60 right here to damage. And then when you go to click on the console tab right here, and then when you hit play, it should start. And then after a second, it's going to say damage is equal to 0. So it's just gonna, actually, I just realized we could probably have a better example for this. Here, let's go back to your code. Yeah, once it hits 0, okay. So here we can have it go every frame. It tells you a certain information, debug log, and then we type in damage. So every frame that it plays is going to tell you in the console that that's how much damage is worth. So since we want to make it last longer, we can make this like 1,000 or 10,000. And then we go back. We remember to save. Then we go back to our script. And then I think we also have to, we can make it reflect that here. All right. And then when you hit play, you could see here. Then you can also hit pause to like pause at that specific moment in time. Uh, you can see here when you look up the debug log, it's going to show every frame. It's going to print out like how much damage is worth. So it's going to print out like that specific number. So yeah, that for the most part, that's really like most of the basics to Unity. Really, it's just like setting up the 3D objects or setting up your objects and then adding scripts to the thing. Next week we're going to be going over how to like get these characters to move, and yeah, we'll be writing an entire script for that. Are there any questions by anyone right now?
Is there any like material you guys recommend like to learn further on this?
Any type of material that we what? Sorry.
Like that you recommend, like books that you guys use or videos?
Yeah, we could send out some tutorials later on. There's a one YouTuber that I watch called Bracky, and basically he's been doing this for like 10 years or something. But yeah, he has a lot of good tutorials. We can send out references to him and some other YouTubers that we watch. And like as you're programming, obviously here we covered 3D, and some of the other games might go into something like 2D. If you have any struggles with 2D, you could always ask in the questions and concerns chat, or you could always like Google it yourself and then see like the different tutorials that are offered there. Enzo put down the Bracky's YouTube channel. That's where, for me personally, I learned a lot of stuff. And then, yeah, as I said, next week we're going to be going over the player controller. So we'll be able to get our player to move around. Are there any other questions?
If I can also point out one source of guides, it was last semester. Nandan, or one of our webmaster, we put together like a video series. So that's also like he went through and edited all that. So that's also a nice intro to, well, I forget. I think it was geared a little more at people who are knowledgeable in Unity, but we do have stuff on our YouTube.
Yeah. I could send that out also later in an announcement. And then along with the announcement after this meeting, we'll also be sending out the GitHub basics video where our treasurer Enzo worked on that. And it just helps you get set up for GitHub. And he'll be going into that on depth on how that all works. Are there any? Oh, sorry.
Sorry, I was just going to say we're going to make an announcement right after this that has a link to the YouTube video on our channel. And then you could find all the other tutorials that Daniel was talking about also on that channel. And then the GitHub video is just going to go into the basics of GitHub. So GitHub allows you to collaborate with your team, basically to work on projects together. So the video just goes over how to set it up and then the basic commands to use it.
All right. That's all for our first workshop. I hope you guys enjoyed it. Are there any other final questions? All right, cool. It was nice meeting all of you. Have a good day.
Thank you for coming.